Good morning and welcome to Johnson Space Center. We have here today representatives from NASA and the European Space Agency to talk about a new agreement signed that's going to get ESA involved in the work on NASA's new spacecraft, Orion, that's going to take humans farther than they've ever been before. Here to tell us about that today, we have to my left, Bill Gerstenmaier, who is the NASA Associate Administrator for Human Exploration and Operations. Then going down the line, Tomas Ryder, ESA's Director for Human Spaceflight and Operations. Then Mark Geyer, the Orion Program Manager, and Bernardo Patti, who is the ESA Manager for ISS Operations. We'll let them start out with a little bit of introduction on what exactly is going on, and then we'll take questions here from the audience. Thanks.
Okay, thanks. As you described, the Orion capsule is the vehicle that's going to take us really beyond low Earth orbit and allow us to move human presence out into the solar system. And sitting behind that Orion capsule sits a device called a service module that provides some critical supplies and propulsion for the Orion capsule itself. And what we've done is we've got an agreement with our European partners to essentially have them develop the first service module and portions of the second service module for the Orion capsule. And this has been a really pretty amazing activity. We'll describe it and discuss with you more as you ask us some questions. I had the privilege today of attending a ceremony. We did an award ceremony for the Orion team and the European team for the amount of work that they've done in getting prepared to get to this moment. To make a commitment this big, there needs to be a lot of engineering done behind the scenes to make sure that this is really the right thing to go do. Can we really integrate these two vehicles together? Where do you define the interfaces? How do you make this happen? And the teams have done just a tremendous job over the past several months of figuring out all those technical interfaces. There were also intergovernmental agreements that needed to get put in place, some other activities that needed to be done, and we spent a little bit of time today to recognize the folks, the teams that actually did all that work. And it was pretty amazing just sitting there watching the awards get passed out from the Italians that were here, Europeans were here, NASA personnel were here, Lockheed Martin people were here, contractors were here, to see this international team come together and be this commitment. So what we're going to describe and what's represented by this signature is really much bigger than just a simple signature. It is really an integration of the service module with the Orion capsule as we move forward. So it was pretty amazing to see that. The other thing that was also intriguing was, this is part of ISS. Some of the funding for this is coming through the Common Systems Ops costs that are owed for the station partnership. So that enabled this cooperation. But I think more importantly than that financial piece is just the experience that was gained through the International Space Station. To build this wonderful facility we have on orbit, we needed to work a lot of technical issues, a lot of technical problems, and that experience gained and that trust that came between our European partners and our NASA teams allowed us to really go ahead and put together this service module agreement that you see today. So again, as we talk about space station being that first step in exploration, it is physically the first step in exploration, but I would say it also paved the way in terms of international agreements, international working together, contractors working together to really take that cooperation to a different level internationally. So again, just a tremendous day to participate in that awards activity, then to be here for this press conference. So I look forward to your questions, and I'll turn it over to Thomas for some opening remarks. Thomas?
Thank you very much, Bill. Good morning, ladies and gentlemen. Also from my side, I have to say this is a remarkable moment for ESA. You can imagine that the ISS cooperation in the past years has already shown some evolution, and this is another step of this evolution, as Bill already has explained here. I would even say it's a new page. We are opening a new page in the transatlantic cooperation. For ESA being involved in the building of a space transportation system, US space transportation system, which will give a perspective for humans to go beyond low Earth orbit. Certainly, low Earth orbit will remain a destination for us. We have a fantastic infrastructure in orbit, which we will be utilizing in the next years. To the end of this decade, certainly beyond this decade, there will be the need also to utilize low Earth orbit for various scientific reasons. But another aspect is, of course, to bring humans beyond low Earth orbit to new destinations. And this cooperation, I think, brings us into this endeavor. It is building upon ATV heritage, as we say. You are very well aware that ESA is providing supply vehicles to the International Space Station. The fourth of these ATVs will be launched in April this year. The last one will be launched next year. And based on the experience that we have gathered in ESA, in European industry, we are now building upon that in the context of this cooperation. Also coming to this award ceremony this morning for, I think, both teams. From our side, certainly, it was a running start. ESA has been working after the last ministerial conference in 2008 on a concept study, ARV, and we very much benefited from this study to come together with a technical team from NASA to really pick up very quickly and prepare all the needed work in order to prepare the decision in our ministerial conference. Also, as a follow-up of this decision, there was an implementation agreement elaborated by both sides. It was endorsed by the US State Department. It was endorsed by the ESA Council in December last year, and now we are really set to go ahead. We are very much aware that a lot of difficult and complicated work is still ahead of us, but that is very inspiring, and I think all of us are looking forward to this fantastic endeavor.
Thank you. So it's a great day for Orion. We get to add key experience on the ESA side that, as Mr. Ryder mentioned, came from their ISS experience in ATV and before. I thought it was important for us to be clear on terminology, so I've got a slide to show a little bit. There you go. Go ahead and go to the next. Okay, it's very good. And it might be hard to see, but these would be available to hand out. When we talk about the different parts of the Orion, it's really important, I think, to pull on the part of how important this ESA element is to the Orion mission, and also relate it to the definition of the different parts of Orion. So obviously at the top is the crew module, and I'll talk a little bit about that later, and a little bit about EFT-1 in a minute. But there are other elements of the Orion that make up the service module. So the service module is really everything below the crew module, and now we've shaded the stuff in gray that will remain with NASA. There's a crew module adapter, which is a very tight tolerance with the heat shield, so we're going to retain that piece. And there's fairings and an adapter to the launch vehicle that we're actually going to fly on EFT-1. And in this deal, we leave that with NASA, right? I think that's the best economical thing to do, something we've already built, we're going to keep. But ESA now will provide that core, as you see, kind of the highlighted white area in there in the middle, which has the propulsion, power generation, radiators, consumable storage. So obviously it's a key part of the service module function. Most of the gray will fly on EFT-1, and the ESA part will allow us to move on to EM-1, which is the flight in 2017. So Mr. Ryder said it very well. We didn't just start yesterday on this. The team has been working this concept for a while. We actually did a system design review last year. They're here this week, actually working details to get us to a preliminary design review and to move us forward. I think it's great that we're using the ISS experience, not just technically, but working together. A lot of the same experts are working on both sides, and we get to apply that to this great exploration mission. Orion, of course, is not just a PowerPoint picture like that. We're actually flying in 20 months. EFT-1 is flying in 20 months, and we're down at the Cape installing hardware as we speak and doing software testing in Denver. So it's a great time, exciting time for us, both near term and also now with this great new agreement becoming more international as we go beyond low Earth orbit. Bernardo?
Well, just a few remarks. I would like to say that, yes, thanks to the approval of the program by our member states and by the signature of the implementing arrangement between NASA and ESA, now we are starting to ramp up our teams. We are placing industrial contracts, and we are facing the very challenging schedule that will bring us to PDR by the second part of the year. So all the team are extremely excited and enthusiastic to carry on in this endeavor. And well, they are here this week, making good progress. And we look forward for the PDR to confirm that all the expectations that we are building up are going to materialize further. Thank you very much.
Okay, we're going to take questions now. We'll start here in the room with the reporters in attendance, and then after that we'll take questions from the phone bridge. We can start with Mark Rowe.
Thanks. Mark Rowe for Aviation Week. This puts ESA in the critical path for the early development of the Orion and potentially the rest of the SLS and so forth. I wonder if you might talk about the significance of that. That's a different element in the development, and what does that mean in a big picture sense? And I think that's for Mr. Gerstenmaier and Mr. Ryder.
Again, I think you characterized it very well. We put ESA in a critical path, and we don't do that lightly. So as we talked about, we did this. We had this team set up to go review and understand how we would go put all this together. And as Mark showed you in the graphic, we were also pretty smart about how we picked the interfaces. So if you look at the way the interfaces are picked, the primary load carrying capability is through that spacecraft adapter, through those jettisonable fairings on the outside, then up to that Orion module adapter that is critical with the heat shield. So that primary load path is through the outside. So that helps ease some of the integration activities. So we didn't want to give them a technical challenge that would be so difficult that it would be almost impossible for them to pull this off. So we worked very closely. And what's interesting is it wasn't just the NASA teams. We actually brought in the contractors that are going to be doing this work, and we had them help us figure out where to put those interfaces. So we put them in the critical path. I would tell you we probably would not have done that without the experience we've had in Space Station. In Space Station, we've learned the real meaning of cooperation. It isn't actually not counting on your partner to be there. It's actually giving up a piece of the spacecraft or the piece of the work that you're going to do and actually counting on that partner to deliver. So this wasn't done lightly. I'm confident that the ESA team and the industrial team and the NASA teams and the contractors teams can deliver on this thing. But this will build us that first step. So when we talk about international cooperation, it's not talked about lightly here. We are really doing international cooperation, and as we push humans out into the solar system, we're doing it internationally, and this is that first step. So I think it's, it's not 100% comfortable, but I'm never 100% comfortable, so it's okay, and we'll see how it goes, but we've done it smartly. And Thomas, anything you want to add?
Yes, thank you very much, Bill. I would just like to stress again what also you, Bill, have mentioned before. I mean, exploration in future, I think, will become more and more an international endeavor. When we are talking about cooperation, it is not just because of political reasons, but we are looking for synergies in technical, in programmatic way. And that is a very, very good example exactly in that context. As I mentioned in my introductory statement, ESA has proven to be a reliable partner in the context of the space station program. We are operating together with all ISS partners, our infrastructure in orbit. And I think based on that, based on specifically the ATV heritage, I think this is a good choice to make in order to exploit synergies that have been developed in the past and that can be beneficial for reaching common objectives.
Okay, Kevin.
Captain Quinn from KTRK here in Houston. For Mr. Gerstenmaier, number one, you mentioned that you're not 100% comfortable with this. Can you expand on that, please, and explain why there's still that lack of 100%? And then number two, can you explain also for folks at home, big picture, what does this mean for our ability to get beyond lower Earth orbit for the first time in 40 years?
Yeah, I guess my comfort words are really kind of my words, right? In our world, we're really pushing challenges and we're doing things that have really not been done before. This capsule we're talking about is going to go beyond the distance to the moon. We're going to go extend beyond that. It's going to eventually be the vehicle we will use to go to asteroids and to Mars. And if I told you today I'm comfortable with all this stuff and all the design sits there, you should be asking me, how can you be comfortable? And so I think as a common person looking forward, these are challenges, but we're not foolish, right? And that's why we chose the interfaces where we did. That's why we had the contractors talk to each other to evaluate up front to make sure things that are all right that are there. We've got a very tight schedule to do it, as Mark and Bernardo talked about, the preliminary design review later this year. I mean, that is really fast in terms of development. But again, we've done a lot of preliminary work up front. We're taking advantage of some heritage hardware, so all that works. But I'm a realist in the fact that I know that this won't be easy. And if I was comfortable and I was up here, then you should be questioning me what's wrong with me. So the fact that I tell you I'm uncomfortable, that's exactly where I want to be. That's where I want my team. I want them pushing. We're going to be innovative, creative, push forward, and work in an international and cooperative manner, and we'll do that. But it doesn't say you have to be comfortable when you go do that.
Okay, Gina?
This question is for Bill and for Mark. How tough is it to design a system like this when you don't know exactly where you're going? You know you're going to go to the space station, but you don't know if you're going to the moon or Mars or an asteroid. I mean, Mark, when I interviewed you last year, the plan was an asteroid. Well, how do you design a vehicle when you don't really know where it's going to go?
I would say we have the basic requirements understood. We know what change in velocity or how much propellant this vehicle needs to carry. We know what its basic structural load capability is. We know how long the life support systems need to be there. We know how many crew we're going to carry. So we know all those parameters. So, you don't design a car to just go to the grocery store. You design a car that can go to the grocery store and go to the shopping mall and maybe drive across the country, do other things. So it's the same kind of thing here. As engineers, we take those basic requirements to do these multiple destinations, these multiple locations, and we're building a system that will allow us to go explore those. We no longer want to build a system that is optimized for one particular destination. We want a system that can actually push human presence out into the solar system and allow us to go all these different destinations. So what we've done is we've broken that down into the requirements that allow us to capture all these destinations, scarred some interfaces to grow a little bit in the area. So I think the teams are very comfortable with what we've laid out in front of them, and they understand the requirements they need to build to.
Yeah, Bill said it great. I would just add, so this vehicle has a lot of capability to do a lot of different missions. When you talk about volume and delta V and ability to carry crew, it's really got a lot of flexibility. So we participate in those architecture studies that happen at headquarters as they talk about new missions to make sure that we understand what if any updates we would need to make. But even at this point, even with all those different discussions, our plans for EM1, EM2 haven't changed because this is a very capable vehicle.
Okay, I don't see any other questions here in the room, so we'll come back later for follow-ups, but for now we'll go to our phone bridge. We'll go in the order that you called, and if you could be sure and address your question to the person who'd like to answer it, that would be helpful. We'll start with Lisa Grossman from New Scientist. Lisa, you may need to take your phone off of mute if you haven't. Okay, we're going to move down to Brian Bastag from Washington Post.
Hello, this is Lisa from New Scientist. Are you guys still there? Did I miss it?
Yes, go ahead, Lisa.
Okay, great. I was wondering if you could lay out a little bit more clearly which parts of the vehicle are going to be NASA-based and which are going to be ESA-based and what that means.
Sure. Can you see the graphic where you are?
Yes.
Okay, good. So I think they put up the right one. There's a picture of it. The stuff in gray, if you look, I kind of had them gray it out so it was a little easier to delineate. That is the NASA and Lockheed built spacecraft pieces. What you don't see on there is the launch abort system, which is where obviously NASA is retaining as well. But the gray parts, which again are the command module, and then really structural interface pieces, the fairings, the spacecraft adapter to the launch vehicle, and then that crew module adapter, which interfaces with the heat shield in the crew module. So the white part there, again, is the core piece, and ESA is providing that. And as I said, it has the solar rays. You'll notice also in the pictures now, the Orion will look different. It'll the arrays look a lot like an ATV, so I think that's a visual representation of this agreement and the changes that we're making. The radiators are on that part of the spacecraft, obviously the key propulsion elements. There's storable consumables for the crew and so forth are in there. So a lot of key elements that will be provided by ESA.
Okay.
Does that answer your question?
And how is this different from what was being planned before?
Before, the entire element that was in white was a NASA Lockheed element that would be provided. So again, this deal is for EM1. So for the first flight, this white highlighted area will be provided by ESA. In the past, the entire vehicle was a NASA Lockheed vehicle.
Okay, thank you.
Okay, now we'll go to Brian from the Washington Post. Okay, I don't hear anything from Brian now. We'll move on to Amy Spitak from Aviation Week. And everybody be sure and mute your phones after you've finished asking your questions.
Hi, my question is, I guess for Mr. Gerstenmaier or Mr. Geyer. Will development of the module include flight-ready spare hardware for missions beyond the 2017 flight? And if so, who is going to own that hardware? And will European industry be involved in those missions, even if it means additional costs, or would production of the module stay in the U.S.? Thank you.
The agreement includes this, the highlighted area in white will be provided by ESA. That includes a sparing, what you call a rational sparing plan, where you buy one of a certain set of items so that if something breaks in manufacturing or testing, we have spares for that. So that's the agreement. ESA also agrees to support the sustaining engineering of that element. So as we're doing testing or flying it, that they'll have the expertise needed if we have questions. Of course, it's a highly integrated vehicle. None of these pieces fly by themselves. In fact, the CM and the SM don't fly by themselves other than the last few seconds after separation. So it's a highly integrated vehicle. We'll be tied to the hip from now until through the flight with engineering, and ESA is supporting that in their plan.
And in terms of the kind of the future activities, we really haven't defined that at this point. We've set up for the EM1 mission, as Mark's described. We've got some spares, key components for EM2. We'll see what we want to do with that mission, and then beyond that, we've protected both ways. We've made sure that we've kept the right intellectual property that's available to us on the NASA U.S. government side, that we can manufacture the follow-on service modules if we need to on our side, or if we decide that it's advantageous to us to continue in those future flights with the Europeans, we can work with the Europeans to do that. So we've really made no decisions about those future flights. We think it's important to set this up on the first flight and then plan kind of for that transition second flight. And then beyond that, we'll work together again as an international team and figure out what is the best thing for us in terms of human exploration, and we'll figure out the way to do that as we go forward.
Okay, we'll go next to Ken Kramer with Spaceflight Magazine.
Hi, thanks for taking my question. I guess I'm wondering about the ATV, maybe for Thomas Reiter. How much of the EM2 SM module would you build? And I wonder if an ESA astronaut might be aboard that flight, which I think is going to go to the moon in 2021 or 2022.
Well, thank you very much for this question. As you can imagine, I mean, I addressed in my introductory remarks that this cooperation opens new perspectives for bringing humans beyond low Earth orbit. And certainly this is one of the areas where I will start discussing with Bill what possibilities there are. But at the moment, I think we are focusing really on the technical work that needs to be done. There are programmatic implications, and certainly this is one of the things we are having on our list to discuss for the future. I think it would be a fantastic opportunity. I said before that this exploration in future is more and more becoming an international endeavor. And in that sense, I think a kind of international crew would also testify that, as it does today on the International Space Station. But once again, for the moment, our focus is really on doing the technical, the programmatic work that is ahead of us.
Great, thanks. And maybe for Bill Gerstenmaier or Mark Geyer, are there any significant changes you have to make to the Orion in order to integrate the European vehicle? Thanks.
Yeah, great question. So we've worked really well together as far as getting the requirements set up so we can minimize that, and we want to make sure that the Orion performs as we've committed that it'll perform. So as far as its performance, it'll be the same. So that's great, and the team's done a great job. Obviously, there'll be some difference in the structural interface. If you look at if you remember that picture where the highlighted white area now interfaces with that crew module adapter, those on the Lockheed design were one structural piece. So there'll be some difference as we figure out, as we work together on how to attach those pieces, and ESA provides it, and then we do this assembly. But I'd say that's the major piece. We've also updated some computer interfaces. And yet we're going to use the same network interface protocol, so that makes it a lot simpler for us to work together. So I think the team's done a great job in minimizing those.
Okay, next up is Marcia Dunn with the Associated Press.
Yes, hi, good morning. This question's probably for Mr. Gerstenmaier, but I was hoping to get the latest details on what the exploration mission 1 and 2 will entail. Could you just give the latest rundown on that? And I have a follow-up, please.
Yeah, EM1 and EM2 at this point, we conceptually talk about them going to the vicinity of the moon. And that's a pretty broad space, and then we're still looking at what the details are of what we want to go really do with those missions. Are there any things that we want to do in those areas? But it turns out for the initial SLS configuration, that's a very reachable space for us with the SLS configuration. So I would say at this point, we're looking to cislunar space in the vicinity of the moon, and we'll probably put some more details together as I described earlier.
Thank you. I'm wondering if you have a target date for the second mission, and a bigger picture question might be, we hear about L2 outposts corralling an asteroid. What's your preference? What would you like to see the long-term, or I guess short-term, long-term plan for the Orion and SLS?
In terms of major flight milestones, we have the 2014 exploration flight test, which will really be the first flight of the major Orion systems, and also really stress the heat shield as we look at reentry heating of that capsule at about 80% of lunar velocity return kind of speeds. That will inform the critical design review for Orion. Then we have the EM1 mission in 2017, in late 2017, and then we have the first crewed mission of the Orion SLS system in 2021. And those are the basic missions that we've laid out. And in terms of my own personal preference, I really don't have one. What we're doing is we're really looking at all these different options that you've described and you've written about. We'll take a look at all those. We'll try to figure out which one is the best one to go do. And when we figure out that it's the best one to go do, and by best, that's in the eyes of a whole variety of different stakeholders, of which I try not to take an opinion. I lay out the data and we let them decide, and therefore I'm not disappointed. So I won't pick a position, but I'm excited about getting beyond low Earth orbit. I'm excited about getting to the vicinity of the moon. We really have a lot to learn. We went to the moon with Apollo. We went in very focused missions. We didn't really spend a lot of time looking at what it really takes to do operations in deep space. We're very comfortable now, at least in low Earth orbit with the International Space Station. We've had crews on orbit continuously for about 12 years. We understand stable orbit rendezvous. We understand navigation in low Earth orbit. There's a lot to be learned in deep space. And how do we protect our crews? How do we look at return trajectories? How do we look at redundancy in systems? Orion's designed to have some leak in the capsule and still return safely from the moon. That's a tremendous design feature. How do we exploit those features and move forward? So I think, again, we have lots of things to discuss. We'll make those known as soon as we can let them know. They make sense to tell us that that's what we want to go do. But for now, I think it's best we kind of look at all those and look at the advantages and which one allows us to move further and faster into exploration in deep space.
Thank you.
Okay, next we'll go to Dan Leone with Space News.
Hi, everybody. Thanks for having us. I've got one for Mr. Gerstenmaier, one for Mr. Ryder. I'll start with the one for Bill. Is there going to be any ESA hardware on the EFT-1 flight next year? And then separately, Mr. Ryder, since you're over on this side of the pond this week, does this deal have any implications for a possible common crew exploration vehicle that ESA's talked about before?
Okay, first of all, on EFT-1, I'll have to ask Mark. I don't believe there's any ESA hardware on EFT-1, but Mark can confirm that.
No, there's not. Again, we're really, that flight is all really about the crew module and about key separation events. So we'll do a launch abort system SEP, and the fairings will also separate. So it's really, the rest of it is all about the crew module. So this ESA hardware is not flying on that flight. This ESA hardware helps us get to EM1, where we need a fully capable service module.
Okay, so to answer to your question related to kind of common crew exploration vehicle, no, this is now the focus from an ESA side. Let me address in this context that our Director General has decided decided on 3 strategic destinations. Those are low Earth orbit, represented of course by the International Space Station, Moon, Mars, for the moment robotic exploration, but of course with the ultimate goal of human exploration. In the past, yes, we have been doing various studies in the direction of supporting or complementing exploration activities with European infrastructure, making use of the Ariane 5, making use of the ATV. However, this is now where all these activities are basically convening in this cooperation in MPCV. Now, of course, I think this is not the end of the game. This is the start of extended cooperation, and of course we can imagine that in the further path we can expand on that. But once again, I think for the next years till 2017 there's a lot of work ahead of us, and I think this is what we at the moment will really focus on. And the scenarios that will come then beyond, I think your questions, the other questions that have already indicated what will really be the destination then, that will be solved as we go along. At the moment, I think it is important to point out that we find additional synergies, that we build on expertise that is also available with the partners, and that we have actually with this way a vehicle that has a certain operational flexibility in the sense of what destinations then will be chosen.
Okay, thank you, everyone.
Okay, next is Stephen Clark with Spaceflight Now.
Hi, thanks. Just a couple of questions. First of all, for Mark Geyer, maybe, whose responsibility is the engine for the service module? Is that NASA responsibility, and what type of engine would that be? And I have a follow-up.
Yeah, good question. The main engine, we're going to use the ohms from the shuttle. We have those left over from the shuttle. We were going to do that. The NASA side was going to do that anyway. And so now that we made this deal, it made a lot of sense, given that we had an engine that had this performance and capability to make it part of this agreement. So we'll provide the ohms engine to ESA, and they'll integrate it into their propulsion system.
And a follow-up to you, Mark. Could you walk through some of the milestones this year for the Orion EFT-1 testing at KSC, and also could you discuss the cracks that were found in the aft bulkhead? Have those been repaired, and what was the cause of that? Thanks.
Good. Okay. Yeah, a lot of key milestones. So we've got a loads test where we'll actually pressurize the element and then apply load to the outside of the structure to make sure the structure, we're getting the responses we expect before we put all the hardware on board. That'll probably be in the middle of February this year. We're doing the avionics testing in Denver. We'll run through the next version of the software here in the spring. That's key because we're actually testing the power on and functional testing of the software in our lab in Denver before we actually use it on the vehicle in the ONC in Kennedy. So that'll be in the spring of this year. In the summer of this year, we'll actually power on the avionics in the crew module, and we'll deliver the heat shield itself. So those are big milestones. And then toward the end of this year, we'll actually finish and get ready to deliver the element to the launch vehicle folks. So a ton going on this year. Across the country in different subcontractors and pieces of Lockheed and NASA across the country. So it's a huge amount of work this year. Yeah, as far as the cracks go, it's a very complex primary structure because it sees a lot of different driving loads, whether it's a landing load, a pressure load, an abort load. So it's a complex design. The team's done a fantastic job. Given that it turns out that there was an area in the crew module where we underestimated some things like shrinkage of the weld and behavior of some of the materials. And so in that case, we didn't realize we were closer to the margins than we expected in one area on the vehicle. Of course, we had cracks that were maybe, I don't know, half an inch big. They never penetrated the pressure vessel, but you don't want cracks, and that's why you do the test. We've come up with a great plan to basically bridge over those cracks to distribute the load so that we won't see any issues on orbit. As Bill called them dustpan, it's a doubler, so it's basically a piece of metal that kind of looks like a fan. There may be two of them to distribute the load to a bigger area. We'll basically bolt those onto the aft bulkhead inside, and it'll distribute the load, and then we'll be able to do the loads test. We have the design. We're finalizing the analysis now to make sure we're not making stress load worse in other areas as we bolt this thing down. That's normal when you do a doubler on aircraft or spacecraft. That work will fit in within that loads test I described because we have a lot of other work to get ready for the loads test, a lot of other hardware to install that is going on in parallel while we work this crack repair design. So like I said, we'll have that ready to go before we do the loads test in the middle of February. And when in the loads test, as I said before, we will pressurize the element. So we'll test it again. We'll make sure that the repair is good along with doing the rest of the tests of the load test. So yeah, good question. A lot going on.
Okay, next up, Peter DeSelding.
Good afternoon, gentlemen. I think my question is for William Gerstenmaier and Mark Geyer, at least to start. First, did I understand you to say that the IGA had already been signed with ESA? If I understood what happened at the ESA Council in November, the agency only committed to the station for the next couple of years and only a little over half of the funding they need for the service module. So maybe you could give us a clarification of the status there.
Yeah, in terms of the service module agreement, there's an implementing agreement, and that has been signed by both parties, both by NASA and concurred on by the appropriate government agency. So that's in place, and that sets us up to go do all this technical work and all this activities that we described going forward.
Okay, is it a concern for you that they've only approved a little more than half the money they need for the service module?
I don't know if Thomas can address that. I mean, we'll let Thomas talk, and then we'll see.
I think this is the normal process in ESA. We have clearly made with a decision on embarking on this post-ATV5 barter element, a commitment to support station operations till 2020. Now, as in other agencies, I think the commitments for the respective funds are distributed over time. And for the moment, this is the first part that has been committed in the past ministerial in November last year. And the next part will be then decided upon in 2014. So I think this is just the normal way how ESA is deciding on its budgets for not only ISS exploitation, not only for MPCV, but for all programs. And I think in that respect, there is a clear path forward, and there is a clear commitment on a really basic programmatic ground for the time till the end of this decade.
Okay, next we're going
to thanks.
Next, we're going to go to Clara Moskowitz with space.com. And Clara, if you haven't unmuted your phone, you may need to do that. Okay, we'll try instead Bill Harwood with CBS.
Thank you very much. And this is just a follow-up on Peter's question. For those of us who don't track ESA's budget as closely as we maybe track NASA's, what cost figure should go on this, the current agreement, if it's funded throughout through the first flight and the components that are planned for the second? What sort of money is involved here? Thank you very much.
Okay, I have to say at this point, are a little bit reluctant to really talk about financial figures. It is about 60% that has been committed now for the first part. Till 2014, the second share, which is a smaller one of about 40%, will be committed then in 2014. And the overall value, okay, I think this figure is known. It has been published before, is in the order of 450 million euros.
Thank you.
Okay, and last on the list, we have Jim Hillhouse from American Space.
Yes, thank you for letting us talk to y'all. This question is for Mr. Gerstenmaier and Mr. Geyer. There's been some talk about Orion being overmassed. What is NASA thinking about doing to handle some of those issues? And does NASA see any problems with reaching the goal of, I believe I read that it was 4,000 pounds over what the parachutes can handle?
Yeah, great question. When we look at that number, what that really is you take my unmanned flight test article that we're going to fly in 20 months, and if you then add all the crew and all the systems that you would need to fly on EM2, then you add that all up, and we're in that, the crew module itself is in that 4,000 pound range that we've got to reduce. But we're not flying EM2 tomorrow. We have a plan today to get to an EM2 weight that will meet the parachute requirements and also meet the mass requirements that allow us to meet our objectives on EM1 and EM2. In other words, you have to be light enough that the engines can push you and get to the places you want to get to. So we have those targets from Dan Dumbacher, who of course is my boss at headquarters and who actually owns this integrated SLS Orion. We have those targets. The Lockheed NASA team have already allocated those targets to the different systems that we know need to get lighter before we fly EM2. And we also had a bunch of work even as soon as the last couple of months, and we had a big meeting in December where we talked about specific updates that we'll do for EM2, including primary structure, some with the heat shield, and other areas of the vehicle that we know we can reduce the mass on and meet the targets. So mass is going to be a challenge. If you remember on Apollo and the LEM, it was a big deal because any pound of mass you try to accelerate from low Earth orbit to the moon and then get it home and land it, you got to multiply by 9 all the systems that have to support it. In other words, the service module and then upper stage and then the rocket and everybody else that has to push that mass. So mass is an extreme premium. It wasn't Apollo. It was a challenge for them. We have plans to get to EM2, but mass is going to be something that we are going to watch every day, and we're going to have options for reducing all the way up until we launch. And remember, in Apollo, as they flew, they learned more and more about the loads and environments they were seeing, and they were actually able to add capability. Remember, the first lunar lander, I think Apollo 9, that LEM could not have actually landed on the moon and done the mission, but within 2 flights, they figured it out, got the mass down, and by the end of flying Apollo, they were actually flying buggies on these landers. So this is part of why EFT1 is so important. We've got models. We've got a lot of experience. We're going to fly the crew module on EFT-1. We're going to put it at 3,000 miles. We're going to push it into the atmosphere. We're going to land it under the chutes. We're going to get a ton of data about the loads we experience and the environments we saw, and that's going to tell us a lot about where our margins are on the vehicle that now we can attack and get ready for these manned missions. So we have a plan. It's going to be aggressive. It's got to be aggressive, and it's going to be one of the key things we're going to be watching all the way until we fly people. So it's part of the fun of engineering, of making this happen, right? It's not simple. It's not a simple system.
Thank you.
Okay, we'll try real quick again on the two that we missed. Brian Vastag from the Washington Post. Okay, or Clara Moskowitz from space.com. Okay, since we don't hear from either of them, we'll take any follow-up questions here in the room, starting with Mark Carreau.
Thanks, Mark Carreau for Aviation Week again, and I think I'm asking for clarification on a couple of things, just because I might be a little confused. I want to make sure I understand the hardware that's involved in this agreement is for the 2017 flight, and then partial hardware for the next one. And also want to understand the barter agreement where you're working off of the space station in order to do this, and whether this agreement accelerates any of the development for Orion and the service module. I'm just looking for some way to say what each side is giving without without talking about the dollars.
Well, I'll start with what is in this current agreement, which is again for EM1, and it's the systems in that highlighted white area. We are providing some pieces like the main engine, some other propulsion hardware we're actually providing, and some network cards. So there's some cats and dogs that we also provide to close this deal. But that's basically it. ESA does provide spares for EM1. Now, if we use them, because sometimes you have a spare, sometimes because you break something. If we use them, we'll use them on EM1. If we don't use them, that hardware can be applied to EM2. So when Bill's talking about spares and beginning for EM2, it can be those things. Hopefully we won't break the stuff and we'll have it available for EM2. So that's the key. To me, the essential part of this is not whether we accelerated something or not. It's actually initiating international partnership beyond low Earth orbit. That's really the key. Certainly, ESA provides capability here, but we also now have some increased integration, because we're separated. And so that's really what I'd say. It's not really accelerating stuff, but basically initiating this new exploration plan with ESA involved in this first flight.
I think it's also important to note that, we're not reducing the Lockheed Martin contract value. It stays where it is. They'll have to actually do probably some additional work that they hadn't planned. So they won't have to do this service module work, but they'll have to do some integration work associated with bringing this hardware together. So there will be some additional cost associated with that. But then there's some other activities that were phased a little bit later that Lockheed was going to go do that we'll make sure get done in this earlier time frame. So I'm not sure it really, we got to be careful how we talk about this. I'm not sure it really saves us money, but what it does is I believe it builds us a more robust development schedule, because it allows us to essentially move some work that would have been late, and if we would have found a problem in that work late, then that's tough to recover from to try to make a particular launch date. So it allows us to kind of work smarter within the contracts we have to make sure we're going to get to those dates, the 2017 and the 2021 date, with more robustness. So we got to be careful. We shouldn't try to go look at what ESA's contributing and then try to subtract that out of our budget and say we're getting there. We're actually getting a better, more robust design by cooperating together. So the beauty of this is it's helping ESA essentially use that, instead of just building an ATV that it was dedicated solely to space station, they're now getting a capability that can be used in a variety of exploration activities into the future, and Thomas can talk about those. So that's a big advantage to ESA. The advantage to us is that it brings in international agreements and international working right at the beginning. So then that gives us a different flavor of what we may do with some of these follow-on missions, some of the questions you were trying to tease out earlier. This gives us a chance to experience some of that early on and then make smarter decisions. And it also allows us to have a more robust overall design to help us meet our original commitments for EM1. So in a way, this is a win-win for both of us, but it does create a new interface that didn't exist before, and that interface has to be carefully managed, or you negate all those good things I just described.
Maybe some very general remarks about barter arrangements, which so far have been a very important element in this International Space Station programs. Think about the nodes that have been provided by ESA, some other hardware that we have been bartering either with NASA or also with our Russian partners. So I think in general, as a kind of international cooperation, the barter is a very important element. Now, specifically for ATV, as you might recall, in March 2011, the ESA Council decided upon not to continue with ATV 6 and 7, but it would have been basically a replication of the same, where we are in a phase where it actually would be prudent really to do a redesign of major system components or even move into something new. And that was exactly the moment where we started the discussions with NASA if we can barter our common station operating costs and other services in that way. So I think an excellent example where really this barter was really beneficial for both sides, as Bill just explained from NASA perspective, and from our side really to use ATV heritage to strategically, of course, engage in a direction beyond low Earth orbit in exploration, and really to build on this expertise which shares and saves some of the efforts.
Just if you could just clarify, I wanted to make sure that I understood if there was some contribution to the space station that now shifts to this project, or this is sort of a new start, as it were.
What's intriguing is the basic framework of the space station. The folks that put together the agreements at the very beginning, it actually says for space station or exploration. So what's really amazing is whoever negotiated and put together all those fundamental agreements recognized that station would be this first step going forward. So that gave us the ability to go ahead and do what we've just done through this implementing agreement. We had to formalize it in an implementing agreement, but the basic framework was enabled by the basic documentation with station. So we see this as an advantage, and it's really. This is really exploration. So we talk about station as being the first step in exploration. This is really that evidence of that first step in exploration, not just the physical hardware and understanding astronaut health or long duration microgravity. This is also showing how we can use our understandings, our working relationships, our contractor relationships together to move forward.
Okay, and I think we also have a question from the NASA social media online.
Yes, we received a question from @DHolzhauser on Twitter. There doesn't appear to be any extended HAB capability. Are there any hooks to add longer duration habitation capability?
Yeah, and again, what we've been focused on here is we're building the Orion capsule and the SLS vehicle, and then at some point, if we're going to go further destinations beyond, say, cislunar space or to an asteroid, to Mars, those kind of destinations, we're going to need some habitation capability or some larger volume for the crew to actually live in. And then the rescue capability, return capability comes from the Orion capsule. So we do at some point need to start looking, once we start picking destinations, we need to go look at what other hardware elements we need to add, such as a habitation module, et cetera, as we start picking those other destinations. So that's a good point, and we'll go look at those. The other thing I think I would also stress too is, we did this arrangement with the European Space Agency. We're also looking with our other partners throughout the International Space Station program, and then through other exploration activities, looking at partners even beyond the the ISS team to see if there's other contributions that folks might want to be interested in making to help us move into exploration. Because I truly believe exploration beyond low Earth orbit is going to have to be international in activity, and it won't be bilateral. I think you'll see us reaching out to other partners moving forward to find ways to put things together that help us both achieve what we want to go do. So again, if you go all the way back to Station, the beauty of Station was we had a shared common vision. We wanted a research facility in low Earth orbit. Then we figured out how internationally to put together an arrangement that allowed us to actually implement and build the International Space Station. Now today, you're getting to see kind of that first step as we look beyond low Earth orbit. This is that first step in international agreements, which I think will be much larger than even the station international agreements as we move forward in exploration to build all these other systems that was asked in the question that we're going to need to go do these things beyond low Earth orbit.
Okay, thanks for that question.
Maybe
Sure.
If I may compliment to what Bill has just mentioned to the part of habitation module, I think in that context it should also be pointed out that we are using ISS apart from the research objectives that we have as a platform for technologies that are exactly going in that direction. Also on international level, there is a working group, International Space Exploration Working Group, which is looking at different roadmaps in order to define the next steps and the technologies needed. So I think in this context, we should also still remind ourselves that we are using ISS also as a platform for technology exactly in that direction you were mentioning.
Okay, thanks for that question. And you can find other social media outlets for NASA online at nasa.gov/connect. Any other follow-up questions here in the room? Okay, since I don't see any, I think that wraps up our briefing for today. You can find photos, videos, and more information about this and other Orion-related news online at www.nasa.gov/Orion. And we'll go back now to the regular NASA TV programming, but tune in tomorrow for the ISS Expedition 35 and 36 briefings, which begin at 11 a.m. Central. And that's following our daily ISS update. Thanks so much.